Annabelle and Jess are two joggers who run around Lake Wendouree every morning. They both start jogging at a random time between 6 a.m. and 7 a.m. from the boat shed. Annabelle and Jess have an arrangement where either one of them gets to the boat shed. They will wait for up to 10 minutes to see if the other person turns up. If they do turn up, they will run together. If they do not turn up, they will run alone. In order to finish their run on time, they must start running by 7 a.m. at the latest. What is the probability that they will run together on any given morning? So this is the sort of question that's really quite difficult to get your head around at first. But what we're going to do is we're going to use area to help solve it. So if we take 0 to be 6 a.m. and 60 minutes later to be 7 a.m, they can arrive any time within this. And similarly, if we go on the vertical axis, this can also be 7 a.m. So they could both turn up at 6 a.m, in which case they would run together. But if one of them turned up at 0, then the latest the other one could turn up is 10. And similarly, if one turned up at 0, the other one could turn up at 10, and they would just overlap and run together. So they could both turn up 10 minutes into the hour. If one turned up 10 minutes into the hour, the other one could be up to 20 minutes into the hour, and they would still run together. They could both arrive at 20 minutes, or if one of them arrived at 20 minutes into the hour, the other one could be up to 30 minutes into the hour, and they would still run together. And what you can do is you can see that there's a pattern that all of this region here results in the pair running together. So every single point inside that box is a time frame where the two of them arrive and they would be within 10 minutes of each other. So if you just test a point here, one of them's arrived 40 minutes into the hour and the other one's arrived 50 minutes into the hour. And if you go inside there, so you might pick a point roughly here, one's arrived about 47 minutes into the hour, the other one's arrived 43 minutes into the hour. So you can see that at that point, the 43-minute person would have waited 10 minutes and seen the person arrive at 47. So all of this region here results in them running at the same time. So what we need to do is we need to work out what that area is. So the area of the red is a funny shape. So what we're going to do is we're going to take the whole box, which is 60 by 60. So that's the area of 60 minutes by 60 minutes, or so to speak. And then what we're going to do is we're going to subtract away two triangles. And the triangle is a half by the height by the length. And the triangles that we're subtracting away is this one here. And hopefully you can see that that length there is 50 and this length here is 50. So we're going to subtract a half times 50 times 50 away. And if you do that calculation, you're left with 1,100. Now the whole area, which is this green box that's going all the way around, is 60 by 60. So the total area is equal to 60 by 60. So that means the probability of them running together is equal to the area of the red, which is 1,100, divided by the total area, which is 3,600. If you do 60 by 60, that equals 3,600. And now if you simplify that down, that's equal to 11 on 36, which is the probability of them running together, which for your interest is approximately equal to 0.3056. So there's about 30 to 31% chance of these two running together on any given morning.